All right, today we're going to continue our review of some functions that you guys have learned before, and today we're going to do quadratic function. All right, so remember what we said in our last day of notes was that a linear function was x to the first power, or x all by itself. Well, a quadratic function is x squared, or we would say the highest power of x is 2, nothing higher. So a quadratic does definitely have an x squared in it, so we have exponents, but nothing higher than that. You're not going to have an x cubed in it or an x to the 10th or anything like that. Now we're going to focus on the graphs today because that's what you guys learned in Math 3, and that's what I want to review with you guys. But basically, the graph of every quadratic is always a parabola, and it can look like one of two things. Here's our two examples here. So our parabola is going to be, and I give you an equation there, we're going to call it y equals ax squared plus bx plus c. That's what's called general form of a quadratic. And then we have two different possibilities depending on the number in front of x squared, which is a. So it says if a is greater than 0, which is another way of saying positive, if a is a positive number, then your parabola looks like a U. It's U-shaped. It opens upwards like a U. Now, if a is less than 0, which is another way of saying negative, if a is a negative number, it flips the parabola upside down, and you get that upside down U shape like you see there on the right. All right, now, a parabola always has a vertex, and that's basically kind of like the point of the U. It's either the very top or the very bottom, depending on which picture you're looking at. And here's an example of both. So in red, you have a parabola opening upwards. That would be one where A is positive. And that black point right there, that's the vertex. So in that case, it's the very bottom of the U. But when the parabola gets flipped, like the blue one, you have the upside down parabola, the vertex is the very top point. But basically, it's whenever the parabola changes from moving upwards to moving downwards, right at that point would be the vertex, or when it changes from moving downwards to moving upwards. It's kind of like it's not really a point, like an angle, but it's kind of like that. Okay, here's another vocab term for you, axis of symmetry. Now the word symmetry, or for something to be symmetric, means the same. Now what we have with a parabola is what we call, it's like mirror image symmetry. Basically, if you take any parabola and cut it right down the middle, it's going to be exactly the same, like a mirror image on either side of that line. Now that line is called the axis of symmetry. So here's an example. Here's in blue is an upward opening parabola, and that dotted red line that's drawn in there, that's what we call the axis of symmetry. It's like a mirror. So if you took your paper and you cut it on that or folded it, so you take your paper and fold it on that dotted red line, the parabola will fold over exactly onto itself because it's a perfect mirror image on either side of that line. Then we get into x-intercepts. Now we're doing a lot of vocab today. I'm reviewing a lot of vocabulary you guys have learned. The x-intercepts are where the parabola crosses the x-axis. And here's an example of that. We have this time I did the upside down parabola, the downward opening U shape. And the x-intercepts are those two red points there, because after I drew in that black U shape, the 2 points where it crosses the x-axis are those red points right there. Now the last vocab term is y-intercept, and it means the exact same thing but for the y-axis. So in fact, any intercept, if you put a letter before it, it's talking about where it crosses that axis. So the x-intercept is where it crosses the x-axis. The y-intercept is where it crosses the y-axis. And here's an example, although I just kind of cut off one side of the parabola. Imagine you have the parabola going like this. It's crossing the y-axis right there at the y-intercept at that red point. So what I want to do to finish up today, we learned a whole bunch of vocab. We moved very quickly, but I'm going to draw a parabola in, and then we're going to label everything that we've learned today on that one picture. So I left myself a blank screen here to do that. Let's make a nice big parabola here. This is our coordinate plane, and we'll say this is our parabola right here. And we're going to go through one at a time and label all of the different vocabulary that we learned today. So let's start with the vertex. I'm going to make the vertex in red. That would be that point right there at the very bottom of the parabola. Okay, the second thing I'm going to do is the axis of symmetry. Now the good thing is the axis of symmetry and vertex are related. The axis of symmetry always goes right through the vertex. If you're going to cut a parabola exactly in half, the vertex is that middle point. So once you found the vertex, if you draw a vertical line, and I'll do a dotted line like our picture before, if you draw a vertical line like this, that is the axis of symmetry. Okay, we have vertex, we have axis of symmetry. Let's do the intercepts next. So I'll do the x-intercepts first. Now the x-axis is that horizontal line that goes right down the middle of the graph. So any points where the graph crosses that, remember the parabola is what I drew in black, any points where it crosses that line, that would be one right here and one right here. That's an x-intercept. And this one over here is an x-intercept. Now we only have one thing to do left, and we'll have labeled everything on our picture. That's the y-intercept, and I'm going to put it right here. So remember, the y-intercept is where the graph, the black graph, crosses that y-axis. And that would be, yeah, that green point right there. So this one here is the y-intercept. So now this one picture summarizes everything that we remembered today about parabolas and about quadratic graphs. So every one is a now the one I drew here is the kind of regular U shape. I could have given you an example with the upside down U and it would have been more or less the same thing. But basically in color, we kind of labeled everything on it. So in red was the vertex, that's a point. In blue is the axis of symmetry, that's that dotted line that cuts it in half. In purple are the x-intercepts, that's anywhere the graph crosses the x-axis. And finally in green was the y-intercept, and that's where the graph crosses the y-axis. All right, I hope this review helped you guys, and I hope you remembered a lot that you've learned before.